In this paper, we introduce a new method for picking objects through quasi-static in-hand manipulation using end-effectors with no degrees of freedom. Our stable manipulation and grasp is achieved with two contacts at fixed distance that don't necessarily need to oppose each other, and the force of gravity. The object is modeled as a rigid polygon placed stably on a flat surface, which is modeled as a sufficiently long line segment. Contacts on the object are modeled as point contacts with friction, and our interest is to keep the object stable within the end effector. Strong notions of force closure will not be attainable in our method due to the lack of mobility of the end effector and number of contacts on the object. We planned the picking operation considering atomic operations, arranged into a feasible manipulation plan for planning. By assuming that the object rotates counterclockwise, we define three atomic operations: type 1 tipping, type 2 tipping, and regrasping. Our end effector can make two types of grasps in terms of moment it can exert. In type 1 tipping, considering a non-antipodal contact pair, the object is tipped counterclockwise by the grasp that can impart positive z-directional moments. In type 2 tipping, the object is tipped counterclockwise by grasps that can impart negative z-directional moments. In regrasping, the end effector is rotated about one of the contact points, and so the sign of the moment of the contact force switches. All of these operations are exhaustive in terms of the relative position between the object's center of mass and the vertex about which it rotates, and are performed sequentially during the planning for picking. As shown in the figure, considering contact C1 initially in contact with the object, contact C2 is rotated counterclockwise until it also makes contact with the object. The position of the center of mass determines whether type 1 or type 2 tipping should occur. If the center of mass is in line of the contact normal, the end effector is controlled to perform regrasping. Another regrasping may be needed to counteract the moment of gravity before lifting the object. We developed a direct drive arm capable of joint torque sensing and a state machine software built upon the mechanics previously discussed. Our Rethink robotic Sawyer manipulator was also tested for object picking and placing. Autonomous picking and placing were performed with a variety of objects. As future work, we plan to generalize our technique and add sensing capabilities, more dexterous in-hand manipulation skills, and more expressive contact models.